Okay guys, this is number 5. We're asked to graph another function. This one again factors nicely. This is an easily factorable one. So the way that we do this one is actually with a u substitution. We'll let u equal to x squared, and then that's gonna let me rewrite this original function as u squared. U squared is x to the fourth, right? X squared is x to the fourth minus 10u plus 9. Then this looks like something I can factor easily. I'm going to have u minus something and u minus something to get, because minus in the middle and positive, right? So I want two things that are going to multiply to 9 and add to 10. That's going to be negative 9 and negative 1. Yeah? Negative 9 times negative 1 is positive 9. Negative 9u plus negative 1u is negative 10u. Okay. So now that I factored like that, I can replace now my u with x squareds. So this is going to be x squared minus 9, x squared minus 1, but I have a difference of squares in both of these cases. So actually that turns out to be x plus 3, x minus 3, that's the x squared minus 9 part, and then x plus 1, x minus 1, that's the x squared minus 1 part. Okay, so now that I have this factored form, I'm going to come back to the original question. I'm just going to write it out in the factored form. The whole point of that is it makes it easy to find my zeros. Now if you wanted to go through that whole process that we've been doing in 3.4 and 3.5, you could, but this is a lot easier if it's clear how it factors right away. Like in this case it is. Alright. So let's look. What does that mean? I have my zeros now. I always write my zeros in the right corner, but since I have no space, I'm writing in the left corner. So here's the zeros. Negative 3. Right? Oh, I'm sorry. I wrote the wrong thing here. That was supposed to be a minus 3. Negative 3, positive 3, negative 1, positive 1. Those are the zeros. Yep. Negative 3, positive 3, negative 1, and positive 1. Each of them has multiplicity of 1, so that means when I draw my graph, it should just pass through each of those points straight through. So let's sketch the graph here. Here's negative 1, negative 2, negative 3. Here's a 0 here. Here's another 0. Positive 1, positive 2, positive 3. Here's another 0. Positive 1, and another 0 at positive 3. This is the x-axis, this is the y-axis. Okay, so next step in our graphing process, we want to figure out what's going to happen as this to this x to the fourth, or in fact to the overall function, as x goes towards negative infinity or positive infinity. So in other words, I want the limit as x goes to negative infinity of f of x, and the limit as x goes to positive infinity, way out to the right, way out to the left, and way out to the right of f of x. Okay, to the left, I'm only looking at x to the fourth, right? And when I put in a negative, really big number, raised to the fourth power, that makes it positive regardless of if it's negative or positive. So it's going to go towards positive infinity. And same thing for here. If I put a big positive number raised to the fourth power, it's going to be a positive infinity. So my graph should go up as I go to the right, and should go up as I go to the left. So up and up. So something like this. Up, and it should be up. Now I know it's going to cross through each of these roots, so the sketch of the graph should look something like this, cross straight through, because it's a odd power, cross straight through, and then cross straight through. So this is a sketch of the graph already. Now if it helps you to actually figure out more details, you can do that interval thing. The next step would be to pick a number to the left of negative 3, so like negative 4, and then pick something in between, so like negative 2, pick something in between, 0, pick something in between, so like 2, pick something to the right of that 0, so 4. Plug all those points in, and then you get another point that you can plot, like this one, this one, this one, and like that one. Right, but I'm going to skip that step because I think it's kind of it's kind of like troublesome. So I just want a general picture of what the graph looks like, and that's, I think, good enough right there. Does it follow my rules? Yes, it goes towards infinity on both sides. And does it hit the zeros the way that it's supposed to? These are single multiplicity zeros, and it just passes straight through. So yeah, we're good.